Hi everyone. So for my second homework problem that I'm going to solve, I'm doing it from the Optics for Spectroscopy homework set. These are numbers 2 and number 3 from the diffraction and interference section. So the question asks us around what width should a door be to diffract a sound wave of frequency 225 hertz, and the speed of sound, just reminds us, is 343 meters per second. So I'm going to go ahead and start by solving for the wavelength of the wave, just by putting the speed, 343 meters per second, over the frequency. And I'm going to calculate that really fast. So that's 1.52 about. And now the equation I'm going to use to solve the width of the door, we're solving for A here, is an equation that we got in class that deals with interference and the space of a slit. So I am going to go ahead and assume that the door is open all the way, so that the angle is going to be about 90 degrees. And M is the number of wavelengths that you have in a wave. And so I'm just going to assume that this is 1 for the sake of this problem, because the problem doesn't indicate that it's any different than that. So I'm just going to go ahead and solve for A, and I know that that's going to be M times the wavelength over the sine. And sine of 90 equals 1, so we can just cross that out. And we know that M is going to be equal to 1 as well, so A equals the wavelength, and based on how we solved it above, A is going to be equal to 1.25 meters. And then for the third part, or for number 3, the question asks what wavelength of light will yield a second minimum, so M is going to equal 2, at 19.5 degrees. So theta will be 19.5 for a slit that's 3 micrometers wide, and that's going to equal A. So I'm just going to go ahead and plug these in and solve for the wavelength. So I've got 3 micrometers. I'm going to convert that to meters times the sine of 19.5 degrees equals 2 times the wavelength. So using my calculator, I'm just going to go ahead and say 3 times -6 equals that, times sine of 19.5, and then I'm going to divide that by 2, and I end up with a bunch of zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is equal, this has 501 nanometers is the wavelength, or 5.01 times 10 to the -7, I think, meters is the wavelength. And that's how I went about solving numbers 2 and 3.